Double replacement. Okay. Solutions of potassium iodide and lead 2 nitrate are mixed. Sarah, can you give me the left side? Ki
plus PB NO3 parentheses 2.
Good girl. And these are both aqueous, correct?
Mm-hmm.
Okay. Give me the right-hand side, Lucas.
KNO3
KNO3
and PBI2.
PBI2.
Where did we get that 2 from?
Say it again.
The 2.
Because lead is +2.
Okay. Wait, why doesn't it go by the lead?
What do you mean? I'm sorry.
The lead 2 nitrate. Why doesn't the 2 after the NO3 go behind?
But yeah, okay. When I say lead 2 nitrate, I'm not saying lead 2 nitrate. Okay. I'm not telling you like how to write it out. I'm telling you that lead with the charge of 2 nitrate.
Okay.
Because there's lead 4 also. Okay. All right. Please whip this out because this is the last day you get to use it. Do you have one of these? Whip it out. Here we go. Okay, let's start right here with this one. Does rule number 1 apply? Yes. Let's get this straight. Alkali metals. You see these guys? Any one of these. Soluble. Soluble, soluble, soluble.
No exceptions, right?
Okay? No exception. Class, what does the second rule say?
NO3.
NO3, soluble. So this is aqueous. Alright, the next guy. Does rule number 1 apply?
No.
No. Rule number 2?
No.
No. Rule number 3?
Yes.
Yes. It says anything that contains iodide is soluble.
But there's exceptions.
However, see rule 5 for exceptions.
So exceptions override.
Yes. And then it says, rule number 5 says anything with lead 2 iodide. So this is your solid.
So does that mean lead 4 would be
soluble.
Okay.
This might be dumb, but what makes it a salt?
A salt is an ionic compound, a metal and a non-metal.
Okay.
Anything that's one over here, ionic compound. Okay. All right, I think I need to balance this. I see 2 nitrates here, so I'm going to put a 2 right here to have 2 nitrates there. That gives me 2 Ks here, so I'm going to put 2 K right here. That gives me 2 iodides here, and I'm all balanced. This is very, very important, and my students saw this last year, so sometimes it takes twice to finally actually understand it. That's good. This might be new to some of you guys. Okay? This is 0.1 molar potassium iodide solution. 0.1 molar potassium iodide solution, Ki solution, which means it's aqueous, right? Okay. The 0.1 molar doesn't really matter right now. Okay, that's just the concentration. Now, here's what everybody needs to understand. And I'm going to pour just a little bit in here. Okay. Inside this bottle is water. Okay. And then I took a salt, whoever asked about a salt, I took a salt, Ki, okay, and as soon as it hits the water, it does this. Okay? And so, what's shredding the gnar?
Shreds the gnar.
Shreds the gnar. Okay, so I'm shredding the gnar, and I've got potassium ions, K positives, floating around in there. I've got I negatives floating around in there. I don't have Ki.
Yeah.
Are we clear on that?
Yes.
Okay. So even though I write on the bottle Ki, I don't have Ki. Can I get Ki back?
Yes.
How?
If you evaporate
If
the
I
water.
evaporate all the water, it's going to come back. Yes. Okay. But as of right now, I've got K positives, I negatives, which means it's electrolytic. Okay. It's electrolytic. There's positive ions. There's negative ions. Therefore, it should. This is a conductivity tester here. It should conduct electricity. Yeah. Is that what your question was?
Yeah.
Yeah.
So if it's aqueous, it's...
Now, no. Yeah, that's a good question. Just because it's aqueous, does that mean it's an electrolytic solution? No. No. If it's an ionic salt in an aqueous solution, then I have that. Okay? Alright, so that's Ki. So this right here is 0.1 molar lead to nitrate solution. I'm doing this reaction, by the way.
Yeah.
Right. Okay, I don't know if you guys caught that. Okay? So, you tell me, what is inside this bottle?
Lead.
I had lead to nitrate, I went in there, and now I have lead plus 2 and nitrates. Matter of fact, how many nitrates?
2.
So there's 2 for every one. Right? Okay, so that's what's in here. And I have another one. I don't know if this one works as well or not. Let's find out. Was it glowing?
Yeah,
a little bit. It's trying.
That's true. Let's see what happens if I use this one, if you can see it better. There we go.
Yeah.
Okay.
Doesn't seem like it glows as bright as the other one.
I like that guy. Okay, so now watch. Are you ready?
Drum roll.
Oh.
So legit. Mustard.
Okay, now, what was that chunky yellow stuff?
Precipitate.
The
Precipitate.
PBI.
PBI2, that stuff that's right up there. See how we're doing that up there?
Yeah.
Okay. The PBI2 is that bright yellow precipitate, which, by the way, was on an AP question, multiple choice. It says, which of the following is a bright yellow precipitate? That was a multiple choice question. Of course, the answers, which were A, B, C, D, and E, was not a precipitate at all, not a precipitate at all, not a precipitate at all, precipitate, not a precipitate at all. So it didn't matter if you didn't remember which one's yellow or not. That's how you got through that.
Is lead usually yellow?
No, it's not.
No.
Okay, so
It's just the actual compound itself. You'll see lead, like sulfate, makes kind of a blackish kind of precipitate. Now, somebody a long time ago asked a great question. And they said, well, will it still light up? This is just distilled water. I'm just rinsing it off. Will it still light this up? And what's the answer?
I don't know.
Are there still
The answer
positive
is,
and
I don't
negative
know.
ions?
Yes.
Probably not.
Why do you say yes?
There's
Because
still positive and
There's
negative
still
ions.
positive and negative.
KNO3 is a
Wow, that is brighter than ever.
There isn't a really strange Swedish film.
Okay, here we go. Ready?
Yeah.
So, didn't I say that this is really just ions?
yeah.
So watch what I do here. 2K positives
Oh, we're doing
floating
this.
around, and 2I negatives floating around. Right?
Right.
2K is 2I.
Uh-huh.
Okay. Same thing here, right? Lead nitrate, didn't I say is doing this?
Yeah.
So PB plus 2 plus what?
2.
2 nitrates. Okay. What about this guy? That's why it was
Yeah.
still electrolytic after the reaction, right? Okay. So 2K positives and 2 nitrates there. What's that guy?
Solid.
It's just
A
lead
rock.
iodide.
Yellow.
There's no ions. It's yellow, yes. That's it.
Wait, so you write it together since it's a solid.
Right.
Okay.
Okay. All right. Does anybody see what's called any spectator ions? Spectator ions are ions that spectate. They don't do anything. In this reaction right here, does anybody see anything that didn't do a darn thing but watch the whole thing?
Potassium.
See how I have 2 potassiums here, 2 potassiums here?
You mean like they didn't change?
And
They didn't do anything. They're still just doing that. They're still shredding the gnar.
Shredding the gnar.
Wait, what about nitrate?
What about nitrate?
Surfing around.
Shredding the gnar. Right? So what's left over? What is the real chemistry that took place that I just showed you? Lead ions and iodide ions hooked up to make
Lead iodide.
lead iodide. This is the answer I'm looking for.